Welcome to June 23rd's LeetCode Challenge, Reverse Linked List 2. Given the head of a singly linked list and two integers left and right, where left is less than or equal to right, reverse the nodes between of the list from position left to position right, and return the reversed linked list. So we're given the linked list here, 1, 2, 3, 4, 5, and we're given left equals 2 and right equals 4. So we're saying at index position 2 and position 4, everything in between is reversed. So we know that position 1 and position 5 stays the same. So we have 1 connected to 4 now, which is connected to 3, which is connected to points to 2, which points to 5. So we have it in this order here. So notice how everything outside the bounds stays the same, while everything within the bounds are reversed. In this example here, we have 5, and left and right are both equal to 1, so therefore the node stays the same. Here the constraints are everything's less than 500, and between negative 500 to 500, and then 1 to n, and everything is left and right. Can you do it in one pass? The answer would be yes. And let's see how we're going to do that. So I think my solution is probably called the iterative linked list reversal. So we're gonna do it in one pass, where we're gonna go through each element in our between left and right, and we're gonna do so in order, if you normally work with a linked list, you have something called like pointers to them. So using a double pointer method. So you have point to this one, the head, and you point to the next one after that. So the trick to reversing this, using this reverse linked list idea, is to have a third pointer to keep track of everything. So I'll kind of walk through the solution here, how I think of it. So the first thing you want to do is initialize a let's call it a dummy node. Dummy node, linked list node, linked node at 0. So we make a dummy node, and we have dummy equals next dot head. So we made a dummy node here with capturing 0, and then we have the pointer dummy dot next, so the pointer from the dummy node to head. We point that towards our head variable. Next thing we want to do is define two double pointers, a previous pointer and a current pointer. So we're going to have a priv and cur, and that's going to be assigned to dummy and head. Alright. So next thing we're going to do is do a for loop. So for I in range of left minus right, minus 1. What we're going to do is for each element within our, for left minus 1, what we're going to do is we're going to update our priv to be previous.next. So update our pointers from previous to previous.next, current pointer to cur.next. We're going to update our pointers to the next element. And then for j in range of right minus left, I believe, yeah. What do you want to do now? What we want to do is left minus 1. Yep. So we want to do so now we have 2 pointers, and we have a third pointer as well. We're gonna do kind of like a 3-way handshake using pointers. So the first thing we want to do is update we're gonna make a temp variable here. This is our third pointer, and we're gonna assign that to cur.next. So temp is holding on to cur.next now. Next, we want to update cur.next. Cur.next can hold on to temp.next. Right? We're doing a 3-way handshake here. And then temp.next is going to be updated to prev.next, previous node. And then our previous.next is going to be equal to our temp. So all this is saying is that we're assigning we have 2 pointers, we have a temp pointer as well, so we have 3 pointers now, and we're going to do a 3-way handshake to reverse each element. So for example, if you were to point to say 3 here, what you want to do is basically have 3 3 here, 3 point to 4 to 2. So we have that pointer there, and now this pointer is going to be assigned off 3 and onto here. However, we still need to hold on to the 4 here because we don't want to delink our linked lists. I'm going to do a 3-way handshake. At the end of this, we want to return our dummy.next because that's holding the entire linked list together. So let's run the code and see if it works. And in range. Okay, looks good. Alright, accepted. So this is could be considered a double pointer method using previous and cur, and then we also introduce a third temp variable into there, third pointers into there as well. So we move these 2 pointers left minus 1 times, and then we invert it with right minus left times. So in terms of time complexity, we have big O of n, and space complexity is constant space, so big O of constant time for space. Let's see, can I add anything else to this? Yeah, because we have big O of n for space complexity, time complexity I should say, because we have n amount of nodes within our node list. We process each node at most once. So after each node, we have processed n times. And for space complexity, it's also a constant space because we're just adjusting the pointers as we move along. So that's all this keeping track of. And then we also have additional constant space for keeping track of this dummy here. Alright, that's it. Have a nice day.